Well, thank you, and it's so good to be back. Yeah, I was just told, like, hey, you get the real deep dive technical presentation, the first one this year. So there's that. This will be technical. It is time to wake up from the food coma. Patrick gave me this great introduction. Well, I have a weblog, Scripting OS 10. No, I'm not going to change the name. Apple can do whatever they want with their operating system. I'm sticking with that domain. I write books. I also work as a consultant system engineer for a Dutch Apple-authorized reseller for a warehouse. When we plan this, we do this in January, February. We have to hand in a topic and have to say, like, okay, we think this will be interesting in 7 to 8 months. And my suggestion this year was, well, I want to pick up on what I did the last 2 years, where I talked about bash scripting, and then I talked about Swift, and I thought some practical examples to follow up on all that theory. Wouldn't that be great? That would be very interesting. Then, of course, yeah, developer conference comes around, and one benefit of the registration opening late was that I got to ask Patrick and say, hey, I want to change my topic. Can I still change that? And thankfully, Patrick was gracious enough to let me. So Apple changed and announced at Developers Conference, well, we're switching the default shell to cshell. And I was like, okay, this sounds like something that I can take care of. What does that mean? And I wrote a post, and I wrote more posts, and I wrote some more posts. And I'm still writing posts, to be honest. Yeah. You don't have to take notes. I will mention a lot of posts that I've written and stuff that other people have done. There will be a ton of links, and it is up on my website with /cshell, scriptingos10.com/cshell. I will link the slides, or they should already be up. And once the video is out, which knowing this team will be in about 5 minutes or so, I will link that too, so you can focus. This is the knowledge base article Apple published on the day after the developer conference keynote, where they announced that, hey, we will switch from the default shell being bash to the default shell being zshell. And they have a few more details, and I will go into that. And that's all the communication we got, too. So what does that mean? Well, the default shell for new users created on Catalina is now bin zshell instead of bin bash. If you upgrade from an older system to Catalina, any users that are present will keep whatever they had set as their shell. Probably bin bash, but whatever they had set. However, if you do run bash on Catalina, you will get this nice warning that is fairly insistent, telling you, well, you probably want to change this. You probably want to stop using bin bash as your shell, and here's how you change it. How did we get here? Let's take a step back, a big step, because the history of shells starts in 1971, or maybe even a bit earlier. We got the Thomson shell, which is like the granddaddy of all shells, and then there were some variants of that. Then we got the C shell and the Bourne shell, which are kind of different approaches to the same thing. And then everything happened, and everything split. And this is not a complete list, just the most important ones, one after the other. Bash has been around for a while. We have had Bash 4 since 2008. But Bash 4 and Bash 5, which came out January this year, are GPL version 3, which Apple does not like, which is why we've been on Bash 3 for a while. If we look at how this looks on macOS, we get a somewhat different picture. When macOS 10 started out, and I didn't remember this either, I was around at that time working, but I didn't care about shells back then. And I didn't remember the details. So zshell and the TC shell, the 10xC shell, were around in 10.0 and 10.1. And the TC shell was actually the default shell. Okay? Bash didn't come to macOS 10 until Jaguar, and it turned into the default shell for new users in 10.3 Panther. I remember back then there was no announcement, probably not even a knowledge base article about this. Main reason adding bash and then turning bash into the default shell was bash was already very popular in the Linux world, and Apple wanted their new macOS Unix operating system to be more attractive for Linux users and admins. So they thought, we'll do this bash thing too. And we've had that bash thing in there for the last 16 years, since 2003. 10.5, Leopard in 2007 got the bash 3.2, and that's what we've had since then. We've got patches. The last patch in 2013 for the shell shock vulnerability. But basically, this binary has been sitting in macOS for 12 years. We're still using it. It still works. But it makes you question, the future of this 12-year-old binary is a bit questionable. So is bash going to be replaced by zshell? Is it time to panic? Because just try to think about how many package scripts in the system, management scripts in your management system, whether you use Jamf, Adigy, FileWave, Monkey, whatever, how many of those do start with bin bash? That's a lot. That's a lot of things that will break if that binary gets taken out of the system. The good news is we don't have to panic yet. As of Catalina, beta 8, I haven't checked the one that came out last night yet, bin bash is still in Catalina, and it will hang around at least until the release. But again, this is the warning shot. Apple is telling us this will eventually go away, and we have to think of all these parts. Some of them are under our control, some of them aren't. When will that happen? Well, that's a big question mark, right? It could be months. Apple has definitely proven in the last 2 years with the spring releases of High Sierra and Mojave that they will make changes in minor updates, in between updates. So I think worst case scenario, we could be looking at 10.15.4, 10.15.5. But in reality, we really don't know. And some things have been deprecated by Apple, like cron or login hooks. They've been deprecated years and years ago, and they're still hanging around and still working great. Fact is, we don't know. Could be months, could be years. What we're getting is zshell. And because I have been asked 3 times today already, it is pronounced zshell. Which, shell names always have these weird things. I mean, you write SH, and it's called the Thompson shell or the POSIX shell. BSH is the Bourne shell, and that gives us the Born Again shell for bash, which is, of course, funny because you bash on your keyboard. And then we have the Z shell, which, of course, only works if you're from the States, because the rest of the world would pronounce it as Z shell. I understand that, but that's not how it's pronounced. Which made me think that there is such a thing as shell namespace. And yeah, I told you it'll get technical. And you can get that with this easy echo command. And there's, in the English Latin alphabet, 26 times 6 combinations with 4 letters that end in SH, and there are 156 combinations. And these are the ones that I know have turned into a shell or something shell-like. So there's room for growing here. We can build more shells. And that does not even include all the great things we can do with emojis. And, since we're thinking hypotheticals here, hypothetically, I started wondering, what if Apple built their own shell? I don't think that's likely. I don't think that'll come anytime near. Maybe I'll be surprised. But just as a Gedankenexperiment, what would happen? How would they call it? Apple shell's kind of nice, but maybe they'll go all retro on us. Or, the more modern things seem to be something like this. Maybe the other way. No, that does not work. This seems very likely. But as I was thinking out these hypotheticals, I realized there's only one thing that Apple would name their own shell, and it would be this. And the beauty of this is, of course, nobody knows how to pronounce it. Is it the 10 shell, the X shell, 10sh, zish? Hypothetical. Yes, I want a part of the income. What we're getting is Z-shell. Z-shell. What is a shell, actually? Because most of you, or some of you, will be sitting here and saying, well, I use Terminal app. What is a shell? Is Terminal the shell? Well, not quite. And again, we go back a long time ago, 4 or 5 decades. Terminals looked like this: electrical typewriters, teletypewriter machines. And they had to connect to a mainframe. And there was a program, a process sitting in between called the shell, because it protected the squishy parts in the operating system from the user, or the user from the squishy parts in the operating system. Depends on how you look at it. The terminal would send the user input to the shell interprets it, sends it to the operating system, executes commands, does file system stuff, and then takes the output and sends it back to the terminal. And because they were teletypewriters, the protocol between the terminal and the shell was called teletypewriter, or TTY, or TTY. Today, computers look different, but instead of having a mechanical terminal, we have a virtual terminal application. And that's what terminal application is on macOS. It's a virtual terminal that takes the user input and displays the process output. And then there's a shell that communicates with the terminal, and that shell actually does all the work. And the protocol between the virtual terminal and the shell is still TTY. There's been, I think, 1 version update or 2, but it's basically still the same as the old mechanical typewriters. A shell has 2 jobs. The first one is the interactive shell. I enter a command, I get the output, I enter the next command, I get the output, might get an error. The interactive shell is chosen in your user record. In macOS 10, it's the user shell attribute that sets, this is my default shell, this is the one I want to use. The second job is to interpret script files. Script files are basically lists of commands. I can have control structures and loops and if-thens and variables, but basically they're lists of commands. Which shell interprets a script file is determined in the first line of that with the shebang in the first line. So I can have a separate user shell. I can use C shell for my user shell, and I can use something else for my script shell. Or I can use C shell for my scripts and use something else for my user shell. Those two do not have to be the same. So what's so great about Z shell? Well, there's a ton of features. If you look on their documentation site or on all the other websites out there where Z-shell enthusiasts tell you why you should switch to Z-shell, they have all these lists of stuff. I will show some of them, but I really don't want to go into too much detail. I want to visualize this with a metaphor. This is an Oma fiets. It's a Dutch grandmother's bicycle. This is the workhorse of the Dutch transportation system. There are thousands of them in each city, even the small ones. This is Bash version 3. Going from this to Z-shell is like going from this to this. The difference is subtle, but there's a battery and there's an electrical motor on this. This is an electric bike. I still have to pedal. The electric motor won't help me unless I pedal. It only assists me, but it makes things easier. I can get farther and faster. And that's what Z-shell does as well. Basically, because Z-shell hasn't stood still for 12 years. Of course, you could get the latest version of Bash as well, but again, Apple won't give us that in the system. Z-shell is mostly famous for having literally thousands of modules and themes and plugins, and there are so many of these that there are module and theme managers for Z-shell. The most famous one, probably Oh My Z-shell, but there's also Presto and Antigen and several other themes, and you can make your command line light up like a Christmas tree. You can argue whether that's good or not. Having some good information, for example, when you work a lot with Git, having Git information in the command line prompt is very useful. How elaborate you want to get with that, it's up to you. Personally, I prefer to do things by hand and get the deeper understanding from getting there by hand. How do I switch to cshell? Well, the good news is you don't have to wait for Catalina. cshell has been in macOS 10 since the very beginning. We've had cshell version 5 since Mavericks in 2013, so that's been a while. High Sierra and Mojave have cshell version 5.3, which is about 2 years old by now, but still works great. And Catalina will come with 5.7.1, which is the most current version as of now. So you don't have to wait. You can switch right now. Even if you support older machines, you can switch them right now if you wanted to. You switch by changing the user shell attribute. So you can do that in directory utility, or easier in system preferences with a context click on the user account. Then you get advanced options, and then you actually get a nice pop-up with all the shells that are available on your system. And you can choose cshell, and then the next terminal window you open. You can also change it in the terminal. The command is change shell or sh-s, and switch to bin cshell because you have to give it the full path. It will prompt you for your password because you're ending a user directory record. And then the next window you open will be cshell. If you want to script it, if you want to manage other users, you can use the change shell command with a username. Of course, you need super user privileges for that. Or you can use discal, or you can edit it in your directory, whatever you need to do. This will not affect your bash scripts. Your bash scripts won't break because you change your interactive shell, because as I said earlier, those two are determined independently. It's the first line in your script, the shebang, that determines who interprets your scripts. If your scripts don't have the shebang in the first line, yeah, then you might be in trouble. So check that, make sure that that still works. The really great news is this is not like moving from Windows to Mac. cshell and bash are both derived from the original POSIX shell or Thomson shell. Their general usage is the same. Some keystrokes are slightly different. I think some international keyboards don't work really well, but other than that, the basic usage is the same. You're fine. Switch, you probably won't notice it. The most visible change is that the prompt changes from a $sign to a percentage sign. I think both are ugly. I'll show you how to change those later. So to get to some of the features, well, if nothing changes, well, there is something that changes. You gain a lot of new features. One of my favorite ones is multi-IO. Multi-IO means that I can take the output stream and redirect it into multiple directions at once. So for example, I have a system profiler command that gives me a text output. And in this example, I'm redirecting it to 2 files instead of just 1. Okay, kind of pointless. But when you realize that a pipe is also another file stream, it gets more useful. So I can redirect the output, store it into a file, and then pipe it into another command at the same time. In this case, I'm just piping it into cat, so I get it into a file and on screen at the same time. That's kind of useful. But in this case, I redirect the output into a file, then pipe it into awk. Awk will filter out, give me the serial number, show the serial number on screen, and also write that into a separate file. So I have 4 pipes in one command going into different directions. Bash 3 does not do this. You just can't. You can mess around with the T command. It just gets very messy and nobody really understands what you're doing. It's very straightforward and simple. Also works with input streams. So I can have multiple input streams into a command. They will just be concatenated one after the other. A bit cleaner to write than with a cat command. This is kind of related, not directly. There's a nice shortcut in cshell. If I write the redirection command for the input, so the lesser than signal, and a file name, it is syntactically equivalent to typing more and the file name. It's just a nice shortcut, which is kind of related to the redirections. Another nice feature is auto CD. I do it all the time. You're in terminal, you start typing a path because you wanted to CD to it, hit return, and then the shell doesn't know what to do because you didn't type CD at the beginning of that path. Well, cshell will assume If it's a directory, you want it to CD there and CD there without the CD at the beginning of the... You have to enable this, though. This is not on by default. You have to enable this option with the setopt command. Another feature that you can enable is correction. And this is much less annoying than it sounds. At first I thought, like, autocorrection, great. This will be like ducking annoying like on the iPhone. It is much better than that. So if you mistype a command or a path or an argument, the shell will try to guess what you wanted to type. And then it will present you with this weird dialogue with the "nyeh" option. The four options are N, no, I knew what I was typing, do as I typed. Y, thank you for catching that, your correction is correct, please execute the corrected version. A, this is so totally mess up, don't do anything. And E, I can salvage this, take me back to the prompt so I can edit. Those are the four options, yeah. Again, correction is not enabled by default in the C shell. You have to enable it with setopt correct. Oh yeah, there we go. There's a bunch more of things, like shared history between windows. Very nice. You probably want to enable that. Extended globbing, complicated. Don't enable it right away. Learn it, enable it later. There are many more. There are nearly 200 options in Z shell. Enabling these every time you open a new window gets annoying, because every new terminal window gets a new instance of the Z shell, and I have to retype my configurations again. And then we get things like aliases and environment variables, and maybe some nice functions and command prompts. You don't want to manually type those in every time. Of course, you create a configuration file with your configuration commands and your configuration settings. And then, when you open a new terminal window, Z shell finds that configuration file and runs it every time it opens a new instance. That way, you can configure the Z shell the way you want to. So what kind of configurations do we have? In Bash, we have bash profile and bash RC, and it's actually kind of confusing which one gets executed when. In Z shell, we have even more. There are 10 possible configuration files. 5 levels all exist on a user level and for the entire system. Of course, the ones in etc affect all users. The one in the user home directory are just for that user. The remarkable one is Z shell env, which will even be launched in scripts. So really don't touch that, because you'll be changing how every Z shell script on your system runs. And that could seriously break things. Then there's a difference between login shells and interactive shells, which is utterly confusing, but the good answer to that is macOS Terminal doesn't care. It executes them all. Treats everything as a login and an interactive shell. There's an order to this. So first all users, then the user-specific one, top to bottom. Apple puts information in these two files. They pre-configure stuff specifically for macOS Terminal in Z shell profile and ZSHRC on etc. The common convention is put your stuff in ZSHRC. If you've been using a bash profile or bash RC, you probably have to transfer the stuff. It doesn't automatically happen, and you want to revisit what you need and what you don't. The management tools, the theme tools that I mentioned earlier, like Oh My Z Shell and Presto, they usually use ZSHRC as well. Read their documentation to avoid conflicts. And consider order of files. The last one in this hierarchy wins. So, since we're system admins, we sometimes have to pre-configure the shells for the users. I think we have two options. On the one hand, we could use etc zlogin, which was the last one on the all users. Because Apple doesn't use that, so we don't conflict with what Apple does. And the downside or upside, depends on how you see it, is that will overwrite what the user is setting in the ZSHRC. Could be a good thing, just be aware of that. If you want to avoid that, you can add one line to ZSHRC, which sources your own configuration file. That will allow you to put it in at the proper time, and in case Apple changes etc ZSHRC in the future, You just have to add this one line again to source your stuff. Again, I think that's a good compromise. Now that we have a configuration file, we can do the really fun stuff, like a custom prompt. Get rid of that ugly percentage sign. The default cshell prompt is really boring. If you're on Mojave or earlier, it's just the computer name and a percentage sign. Catalina is a bit more elaborate, tries to be like bash before. It has the username, the computer name, the current folder, and a percentage sign. That's kind of nice. Let's do something fun. The syntax looks like total hieroglyphics. All these percentage signs. It's well documented, and it's actually not that hard to use. This part will show a smiley face if the previous command executed without error, and a banana if the command executed, sorry, Eric, executed with an error. It's a nice visualization of what the previous command did. This one will switch the text color to blue for highlighting and show the current working directory. And the last one will show the octothorpe or number sign if you're running as root, or a nice arrow as the prompt if I'm as a normal user. And that way I get a very nice prompt shell. I have a post on my blog that goes into a bit more detail and explains more that I can do. Completions, man, completions are wonderful. You know, you hit the tab key and then you work your way through the path. It's nice. You avoid typing errors, you avoid typing, you avoid errors. The default cshell tab completion is pretty much like bash 3. You can complete commands, you can complete file paths. But if you load this completion system with this weird command, you can get so much more. One thing you can get is you only have to type a partial path. So in this case, I can type ULB, and when I hit the tab key, the system knows, oh, this has to be user local bin. There's no other possible completion. Or I can do LPB, and it completes to library preferences by hosts, because there's no other completion. And even if your completion is ambiguous, it will show you the options. This works for arguments and options as well. So most Unix commands have options or flags with the minus sign, and you can get hundreds and hundreds. Well, okay, ls has 56 or something like that. Insane. I used CP because it had to fit on the screen. But if you type the minus sign after a command and hit the tab key, it will know you want an option, and it will list all available options in this context with a short description. Super helpful. You can combine, so you can complete the command. I never know if System Profiler has the underscore or not. I can never remember. So I can use tab completion to help me along this. Then System Profiler has these weird arguments to restrict what it's printing. I can use tab completion to complete those, because the system, the cshell system, knows about the arguments for System Profiler. The same works with complex commands like HDIUtil. HDIUtil has verbs and options, so I can complete the verb. In this case, I want to go for convert. Then I know there's a format, and if I hit tab after this, it even knows which formats are legal for HDIUtil. Don't have to have a second screen with a man page open all the time. Eventually, you still want to, but this helps. High Sierra and Mojave have 6 definitions for tab completion, because cshell doesn't know magically about all these nice things. There has to be a description for this, or a definition. They're basically cshell script files. And cshell 5.3 comes with these commands. The defaults command, very useful. Open software update, System Profiler, HDIUtil, I showed those. If you go to cshell 5.7.1, what we're getting with Catalina, there's way more. Very useful. Of course, there's hundreds and hundreds of standard Unix commands that we also get, but these are the Mac-specific ones. The nice thing is you can write these definitions yourself. The syntax is a bit weird, but you can get there, so I did. So I wrote this one for the Jamf binary, and it completes the verbs and the options for the verb for the Jamf binary. Very, very useful. I have a repo on my GitHub. You can download it and use it. I have these commands so far. I also have a to-do list with commands I think that would be interesting. And I might get around to these one day, but it's open source, so please contribute. Thank you. That's all I have time right now for the interactive terminal. So let's talk about what we really care about. That's scripting cshell. Well, the good news is cshell and bash are very similar. They are derived from the same. So you take your shebang, replace bin bash with bin cshell, and you're pretty much done. That will work in most of your scripts. Most. The rest is the work. There are two differences that you really have to pay attention to, which will be breaking changes between bash and cshell, and that is word splitting and array indices. Okay. Let me recap. I did this 2 years ago in my bash presentation, but I will recap. What does word splitting mean in shell and bash? As an example, I have a function, count arguments. That's just my example. It will put out how many arguments you pass into this function for the sake of the demo. Of course, this stands in for any other function or command that you might use. We have a variable called word list, which has 5 words separated with space. Warning signs should go off for every shell scripter here. And then I use the function substituting my variable word list. And of course, the system will substitute the value of my variable, 1, 2, 3, 4, 5. Then the system will break on the spaces, so I get 5 arguments passed into that. Not the 1 I would expect, but 5 arguments, because the arguments are broken on white space. To protect from that, we double quote variable substitution, always in POSIX shell and bash. And then the content of my variable stays together, and I'm safe, and I get what I expect, my 1 argument. In cshell, it looks a bit different. Whether I substitute with or without double quotes, cshell does the same thing and keeps the contents of my variable together. It's 1 variable, it should stay together, it should not be split on white space. Every other language, I don't have to quote my variables when I use them. In cshell, I don't have to do that either. This is good, this is sane. We're not used to it because we're used to bash and shell, but it's good. However, there are some situations where I might want to revert to the old behavior, and cshell gives me a way out there. I can substitute with this syntax using the equal sign, and that tells cshell, yeah, use the old way of splitting on white space, because I want this in this case. Most common place where you would use that is in for loops, because you want the variable substitution to split, probably, in this case. But an even better way of doing it would be to actually tell the system, I want to split on a space, not just rely on some weird old shell behavior, but actively tell the system, split on this character, make an array out of that, and loop through the contents of that array. And this syntax is weird. It's just something we have to learn, but it's very powerful. I can use it in other contexts as well. So in this case, I get a variable with the system version from the software version command, and I tell it to split on dots, and then I get an array out of that with the elements 10, 14, and 6, which is much saner to use than some weirdly split string. And I can get at the elements using the array index syntax, and that brings us to the next major difference. In cshell, arrays are 1-indexed, not 0-indexed. Yeah, I hear a rumbling in the room. I know, programmers don't like that. I've been using AppleScript since, I don't know, forever, so I'm used to 1-indexed arrays. But cshell, 1-indexed. If that annoys you a lot, you can set an option. If you set the con shell arrays option, KSH arrays, you will get 0-indexed arrays. And the options are live for the context of your script, so you should be safe and not disturbing the environment of the system that way. So that's your way out. Word splitting and array indices. This is really mostly it. There are some other minor differences, but I have not run into them. And I've been starting to transfer my stuff for the last 3 months. Word splitting is a big one that will give you a headache. But other than that, cshell and bash have the same syntax, work pretty much the same. So, scripting cshell, manageable task. the real question is, well, should we still script cshell, or are there other options that might be better? Well, first of all, and I had a slide earlier, cshell has been in macOS for a long time. So I can start transferring my scripts to cshell now and still use them to manage older systems, pre-Catalina systems. So cshell scripts will be backwards compatible because cshell is present on every version of macOS. So that's a good check mark. We're not just being future compatible with this, we can be backwards compatible. There is one exception, however, and that is the recovery partition. Yeah. Recovery partition contains bin bash, including Catalina, at least beta 8. I haven't checked beta 9 yet, but I'd be surprised if they changed that. There is no cshell on recovery. There has never been cshell on recovery. So if you have workflows that run on recovery, like installer, bootstrapper, Mac deploy stick from Two Canoes that Eric mentioned this morning, there are some neat workflows we can use recovery for. If you install a package from recovery and that package installer script wants to use cshell, it will just fail. Interesting enough, we got an addition in Catalina to the recovery, and that's dash. Now, Catalina is this operating system upgrade Apple has told us where they're throwing out old things. We got rid of 32 bits. We want to get rid of kernel extensions. We will get rid of scripting runtimes. They're adding stuff in Catalina. They're adding a new shell. That makes it really interesting right away. So what is dash? Dash is the Debian Almquist shell. It is a minimal implementation of the POSIX shell. It does POSIX sh standard and nothing else. Many other Unix-like systems and Unixes, BSD and Linux flavors, already use dash as the sh stand-in. It's been added to macOS Catalina, including the recovery. Now remember, up to and including Catalina, when I run a sh script or interactive shell, I'm actually running bash. So bash is standing in as sh. There is no real sh binary. It's running bash in sh compatibility mode. And I can see that if I do sh -- version, it'll tell me, hey, yeah, that's actually bash running here. In Catalina, I get a new option to switch which binary takes care of sh. By default, it's bash, but I can change the symbolic link at var select sh to point to zshell or dash. And then zshell or dash will take over the functionality in sh scripts for the POSIX sh. That's fine, right? Sometime in the future, Apple will yank bash. We don't know. Hopefully it's years. And then I assume dash can take over doing the work to stand in SSH. We don't know when. It's fine, right? SSH is a standard. Should behave the same, whether it's running bash as sh or dash as sh. It's a standard. No problems, right? Yeah. One example. I've run into this in the last few weeks. I have this very simplified script. Basically, if the output of the command true is equal to the output of the command true, then we're fine. Otherwise, big problem. Very trivial script. And I run this on bash, everything's fine. Then on Catalina, I switch the shell. And I think that's why Apple put that functionality in there, so we can test. I switch to dash. So dash is now interpreting sh scripts. And suddenly, my script errors. It shouldn't error. It should never get to that point, but it's erroring out. If you've been paying attention, you will have seen this, but this is a hard error to see and to catch. The double square brackets here are, of course, a bash syntax. The POSIX sh standard does not have double square brackets. It has single square brackets. And there are other bashisms, aside from double square brackets, like here documents and here strings, or regular expressions, that are an extension of bash. That's why bash exists, because it is more than the POSIX shell. When you're running bash as sh and it encounters these bash syntax things, bash will be fine with it. Bash will be like, this may not be sh POSIX standard, but I'll just execute it. I'm fine. And it has been doing so since 10.3. If you copy-pasted code from elsewhere into your sh script, the likelihood is very high that you have these bashisms in there. When dash takes over as sh at some point in the nebulous future OS, your sh script will error out. So check your sh scripts for these bashisms. And the tool to do that is, of course, called shell check. Shell check is a binary and a website and an open source project. It's awesome. You can use it to catch all kinds of syntax errors and coding errors in sh and bash scripts. And in this case, had I run my script through shell check, it would have caught it. You can go to my website. I have instructions on how to install the shell check binary on macOS. While you're doing that, also check for Perl, Python, and Ruby one-liners. Because, yeah, we'll get to that later. This is a popular one, made popular by Ben Toms a few years ago. It's a safe way to get the current logged-in user, which we need a lot in administration and installation scripts. This will work even if fast user switching is on and all those weird edge cases. It uses Python to get to the system library to get the currently logged-in user. Eric Berglund last year found a way to do the same with the scutil command. And A, it's much shorter and easier to read, and B, it will work when Python is not there anymore. So check for these things. I see Perl one-liners a lot, because Perl has a very powerful regex machine, and you see those a lot. Why do we care about this? Well, these are the beta 6 release notes when I built the slides, but this hasn't changed. In the release notes, we find that the scripting language runtimes, Perl, Python, and Ruby, that are built into macOS and have been built in for a long, long time, are going away. If your software depends on scripting languages, it is recommended that you bundle the runtime within the app. So Perl, Python, and Ruby. Is now time to panic? We're losing Bash, we're losing Perl, Python, and Ruby. Well, again, Catalina, we got the warning, everything's still in place. Python 2.7, this is actually not Apple's choice. Python 2.7 is deprecated. There will be no more updates starting 2020, so I would assume it's just one security vulnerability away from being yanked from the system. And all we get as the timeline is this future macOS, which again, we don't know. So how do we prepare for this future macOS? And for that, I have a nice chart. On the x-axis, we have the complexity of my workflow. How complicated is my workflow? Most admin workflows, admittedly, are fairly straightforward and simple. We have like 70% of the code is catching errors, and then we do 2 or 3 commands, and then we're done most of the time. Sometimes it gets more complicated, then we need other tools. On the y-axis, we have how complicated is this to manage. And my first examples are sh and bash 3, or bin bash, which are present on the recovery. They're literally ubiquitous on macOS. If you're running macOS, these are there. So easy to manage. Then we have cshell, Python 2, and running Swift binaries, which works pretty much everywhere you have a pre-installed macOS, because they come with macOS, up to and including Catalina. And then finally, we have things like bash 5, which I can install myself to get all the nice goodness of bash 5, or Python 3. And I didn't put Perl and Ruby into this chart, just mentally replace Python with Perl and Ruby if you want to, because the latest versions of Perl and Ruby you can install and manage, but then you have to install and manage it yourself to make sure it's there so you can use it. Now, in some future macOS, these will go away. We don't know when. They might not go away at the same time, but they will go away at some point. Which leaves us with, well, what's on this chart. So for generic automation and workflows in a fully booted macOS, which I think is most of the workflows that we built, something you put in Jamf, extension attributes, Monkey, pre- and post-install scripts, all of these things, I think cshell is a great first choice. The exception being installation scripts. You can't really anticipate in which context installation scripts will run in installer packages. I would use POSIX-shell, the lowest common denominator for installation scripts, just because they might run in a Tucano's MDS deployment on recovery. and then cshell scripts will break. Complex projects, I would recommend either using compiled Swift, binary Swift, or install and manage your own solution. I had to put one first. I'm not saying Swift is better than Python 3. Quite the opposite. For some cases, I think Python 3 would be much more straightforward. This is for complex projects. The disadvantage being, well, you have to manage your own Python 3. But with sysadmins, we install and manage our own stuff and other user stuff all the time. We might as well install our own stuff. I have written a script called pkgcheck that will actually go through packages, mine and third party, and give me a lot of information about the package, including what the shebang of the installation scripts is. And this is one of mine that I built, of course, changing that. But it's kind of interesting running that against third-party packages and talk with the vendors if you find stuff there. Very useful. You can just point it to a folder, and it will go through all the packages in that folder. It's pretty cool. If you want to use something else, you have to install vendor packages, or you have to build your own installer packages. I would recommend when you install something like Python 3 because you want to use Python 3 in your administration scripts, put it in some non-standard location. Reason being, if you have users, developers, who are using Python 3 as well, they probably want a different Python version. They will probably want a separate Python version for each project. Python is crazy that way. And you don't want the Python that you are using to conflict with theirs and vice versa. So don't put it in the standard location. The reason scripting is so great is because they're just text files. I can copy-paste a text file into an extension attribute in Jamf or into MacSysAdmin to run as a post-install, and then the system will just create a temporary file and execute the script. This is really great. Works for Python, works for cshell, works for sh. It also works for Swift. I can create a Swift text file with a shebang user bin Swift, and then I can set the executable bit and execute it like a command line tool. This works as long as the command line tools or Xcode are installed. This requires Xcode or the command line tools to be on the system. So it's yet another thing I have to manage to use Swift. The other thing, if you use Swift this way, Swift scripts, is the compiler is actually cheating a bit because it will actually take that text file, compile it, and run the executable just temporarily, which is great. You know, these are short scripts. We probably won't write very complicated things. But if you consider that you might have 200 extension attributes running this way, and then the system in the background needs to compile 200 short Swift files, run them, and in 15 minutes it does everything again, probably not the most ideal way of using. Swift scripts are nice for like Xcode workflow automation, but probably not for admin stuff. That doesn't mean we shouldn't be using Swift. I really think we actually should. Stood here last year and said it. Swift 5 got us something that is called ABI stability. Just a quick recap from last year. Previously to Swift 5, Swift wasn't ABI stable, application binary interface, which meant that if I had a binary compiled with one compiler version, it couldn't link to a library compiled with a different version. And to avoid that, the compiler would actually take all the Swift libraries and bundle them up in the binary, which resulted in a Hello World binary that is 10 megabytes in size, which is, of course, insane. But with version 5, which came out with 10.14.4 this spring, we get ABI stability. So now, if I compile my tool with Swift 5.1, which came out with iOS 13 and will come out in Catalina, I can link to an older version of the library, which is great, and that results in an executable that's much, much smaller. Very nice. But of course, for this to work, the library has to be on the system. And since Swift 5 libraries didn't exist before 10.14.4, they are only included with 10.14.4 and higher. What if I need to support older versions of macOS? Well, Apple gives us the Swift 5 runtime support for command line tools installer It's a small package. It's only 3 megabytes in size. It's a package. You can install that all the way down to 10.9 is what the package says. I've tested it down to 10.11 because I didn't have an older VM. And that way, your Swift 5 binary will run on older macOS. Just one more thing you have to think of, install this package. So 10.14.4 and higher, we are good. Older versions, install the package. Swift 5 is also required if you want to notarize your binary. Yeah, you need to compile and install the binary, and then you have to install the binary tool. So Swift is a bit more work in the management. But this also allows me to sign and notarize my binary tools. Now, signing might be required if I want to whitelist my tools for privacy exceptions. Notarization for admin tasks is technically not required yet, because all of the ways we install binaries, we're bypassing Gatekeeper, and right now Gatekeeper is what checks for notarization. Right now, up to and including Catalina. Future macOS, I don't know. If you're building your binaries, I would get into the habit of notarizing them. Not required yet, but I'd get into the habit. And that's why I put Swift a bit higher in the management scale here. So, to summarize, we are getting cshell. It's pronounced cshell. Bash 3, bin bash, is deprecated. We don't know when it's actually going to yank from the system. Eventually, it will go. cshell is not that different. They derive from the same roots. We get some really nifty extras. I think it's worth switching. Check your scripts for bashisms. Use shell check. Verify your SH scripts. Check them for Perl, Python, and Ruby one-liners. Again, everything will be fine in Catalina, but in some future OS, these things are going away. These are the options I think we have for preparing for the future. Most of the time, cshell, sh for installation scripts, and for complex projects, either use compiled Swift or install and manage your own runtime. Most importantly, don't panic, but get prepared. With that, I thank you very much, and I think we have time for a question or two.